Good morning, students. Welcome back to chemistry class. Today, we are going to study about molar mass, molar volume, and gram equivalent concept. Okay, today we are going to study molar mass, molar volume, and gram equivalent concept. Okay, first upon molar mass. What do you mean by molar mass? Before that, in last class we studied about that mole concept. So mole, 1 mole means 1 mole is equal to 6.023 into 10 power 23. Okay, so last class we studied. So 1 mole of any substance contains 6.023 into 10 power 23 entities. Entities means maybe atoms or maybe ions or maybe molecules. Okay, 1 mole. If you are taking 1 mole means that substance contains 6.023 into 10 power 23 entities. Okay, so today what do you mean by molar mass? What do you mean by molar mass? So molar mass is defined as the mass of 1 mole of substance. Mass. Okay, today we are going to study molar mass means mass of 1 mole of substance. Okay, 1 mole substance. The mole 1 mole means 6.023 into 10 power 23 entities, atoms, maybe ions or molecules. But here molar mass means mass, how much weight, how much grams are having the 1 mole of substance. Substance means maybe atoms or maybe ions or maybe molecules. Okay, so 1 mole substance, how much weight are having, how much grams are having, that is the molar mass. Okay, for example, mass of 1 mole of glucose. Mass of 1 mole of glucose. You know glucose, what is the molecular formula of glucose? C6H12O6. C6H12O6. This is the molecular formula of glucose. So, what is the molecular mass? What is the mass of this 1 mole of glucose? This is the 1 mole. Okay, 1 mole. 1 mole of glucose. What is the weight? 180 gram per mole. Okay, 1 mole means per gram. Okay, so per mole, how much grams are having? 180 gram glucose are having per mole of the glucose compounds. Okay, so this is the 1 mole of glucose. This 1 mole of glucose, how much grams are having? 180 gram per mole. Okay, per mole means 1 mole, per mole. Okay, per mole of glucose, how much grams are having? 180 gram. Okay, 180 gram. This is the mass of 1 mole of glucose. How we get this 1 mole, this is 180 gram, how we get? So molecular mass, the molar mass we get, how we get? So the molar mass of the compound, this one of the compound, it is equal to the sum of the relative atomic masses of each constituents expressed in gram per mole. The molar mass of a compound is expressed, it is the compound is equal to the sum of the relative atomic masses of each constituents expressed in gram per mole. Okay, so here, so this is the glucose molecule, this 1 mole of glucose. This 1 mole glucose containing 180 gram. Okay, 180 gram of the glucose. The mass of the 1 mole of glucose is 180 gram per mole. Understood? How we get? We should add the sum of the relative atomic mass of constituent. What do you mean by constituent? Constituent means how much the elements are present in the compound. How much elements is present in the compound. This is the constituent. So sum of the relative atomic mass of its constituent. How much constituents are having here? 3 types of constituents are having. What are the three constituents? Carbon, hydrogen and oxygen. Carbon, hydrogen and oxygen. These 3 constituents are having here. So how we get the molar mass? we should add the sum of the relative atomic masses of the constituent. So we should know the relative atomic mass of this constituent. You know carbon, what is the relative atomic mass carbon? 12. Okay, so it is in gram per mole, 1 gram per mole. Okay, so carbon relative atomic mass in gram per mole, this is 12 gram per mole. Okay, so relative atomic mass of the hydrogen 1, and the relative atomic mass of the oxygen 16. Okay, so how much carbon atoms are having here? 6 carbon atom. So 6 into, what is the relative atomic mass of carbon? 12. 6 into 12 plus hydrogen, how much hydrogens are having? 12. So 12 into, what is the relative atomic mass of hydrogen? 1. 12 into 1 plus oxygen. What is the, how much oxygen atoms are having here? 6. 6 into, what is the relative atomic mass of oxygen? 16. So okay, so when we are multiplying this, 6 into 12, 72 plus 12 into 1, 12 plus 6 into 16, 96. So if you are adding these 3, we get the 180 gram per mole. Okay, so the 1 mole, what is the molar mass? Molar mass means, molar mass is defined as the mass of 1 mole of substance. How we get the 1 mole of compound? Molar mass of compound. How we get the molar mass of compound? This is equal to the sum of the relative atomic masses of its constituent expressed in gram per mole. So molar mass we should express in gram per mole. For example, the relative atomic mass of one hydrogen atom, relative atomic mass of one hydrogen atom is equal to 1.008 U. This is the relative atomic mass of one hydrogen. Okay, so suppose we are, what is the molar mass of hydrogen atom? Molar mass of hydrogen atom, what is the molar mass means? Mass of 1 mole. Okay, mass of 1 mole of substance. So here the relative atomic mass of one hydrogen is 1 mole of hydrogen here. So molar mass, it is expressed in gram per mole. Okay, so the relative atomic mass we expressed in U or AMU, unified atomic mass. So the molar mass of hydrogen atom, that is 1.008 gram per mole. Understood? And another one example, relative molecular mass of glucose is 180 U. Relative molecular mass. Okay, 180 U. Relative molecular mass means the molecular mass, it is related to with the 1/12 part of mass of carbon 12 atom. That is the relative molecular mass. So relative molecular mass of the glucose 180 U, unified atomic mass. Okay. So what is the molar mass of glucose? So mass of the 1 molar substance, it is expressed in gram per mole. So molar mass glucose is 180 gram per mole. Okay, so when you are writing the molar mass of the substance, any substance, you should express in gram per mole. That means the 1 molar mass means amount, the gram, okay, weight, the mass of the substance, the mass of the 1 mole of substance, that is called molar mass. What do you mean by molar mass? Very, very important. What do you mean by molar mass? Mass of the 1 mole of substance is expressed in gram per mole. Okay, mass of the 1 mole of substance. Mass of the 1 mole of substance. There is example, molar mass of glucose is 180 gram per mole. 180 gram per mole. Okay, 1 mole means 180 gram. Suppose the 2 moles of glucose means, what is the molar mass of 2 moles of glucose means 2 into 180. 2 into 180. Okay, so 2 into 180 means we get 360 gram per mole. Understood? These are about the molar mass. Then, what do you mean by molar volume? Okay, molar mass we completed. Then, what do you mean by molar volume? What do you mean by molar volume? The volume occupied by 1 mole of any substance in the gaseous state at a given temperature and pressure is called molar volume. Okay, volume occupied by 1 mole of any substance in the gaseous state at a given temperature and pressure is called molar volume. Okay, so volume occupied by 1 mole. Okay, 1 mole. Okay, this is 1 mole of substance. So this 1 molar substance, how much volume occupy? How much volume occupy in the 1 molar substance? Okay, that is in gaseous state. It is not solid and liquid. So in gaseous substance, okay, gaseous substance, gas, the volume occupied by 1 mole of any gas. Okay, at given temperature and pressure, or the given temperature and pressure. Okay, if you are changing the temperature and pressure, the volume will be changed. Okay, volume occupied will be changed. So particular the given temperature and pressure, how much volume occupied by the 1 mole of gas, that is called the molar volume. That is called molar volume. Okay, so molar volume of the volume occupied by the 1 mole of any gaseous substance in liter given in your textbook. So first upon 273 Kelvin. Okay, the conditions are given. The conditions 273 Kelvin temperature and 1 bar pressure. 1 bar pressure. What is the how much volume occupied by 1 mole of gaseous substance? Okay, here how we get the 22.71 liter. Okay, at given which temperature? 273 Kelvin temperature, and what is the pressure? 1 bar pressure. 1 bar pressure. Okay, so what is the volume occupied here? 22.71 liter volume occupied. Okay, this is the 1 mole of gas. This is the 1 mole of gas at what is the temperature? 273 Kelvin temperature and 1 bar pressure. How much volume occupied? 22.71 liter. Understood? So here 1 bar means there is 100 kilopascal. Okay, that is the if you are writing the atmospheric pressure means 0.987 atmosphere. This is the 1 bar pressure. Okay, so if we want to calculate this volume occupied, there is one of the ideal gas equation, PV is equal to nRT. So we want the volume. Okay, volume occupied. So volume V is equal to nRT by P. Okay, by using this formula we can calculate the volume occupied by the any substance, 1 mole of the substance. Okay, at a given temperature and pressure. And another one condition given, 273 at 273 Kelvin temperature and 1 atmospheric pressure. 1 atmospheric pressure we get 22.4 liter volume occupied. Okay, and another one conditions are given at 298 Kelvin temperature. At 298 Kelvin temperature and at pressure is 1 atmospheric pressure. That is the room temperature. Okay, room temperature. So 273 Kelvin means 0 degree Celsius. 0 degree Celsius. 298 Kelvin means that is 25 degree Celsius. This is the room temperature. Okay, so at the room temperature, how much volume occupied? 22.47. 1 molar gas occupied by the 24.47 liter. This is the volume occupied by the given gas. This is the molar volume. Okay, molar volume. Molar volume means the volume occupied by 1 mole of any substance in gaseous state at a given temperature and pressure. Okay, at a given if you are changing the conditions, if you are changing the temperature and pressure, the volume occupied, the molar volume will be changed. The molar volume will be changed. Okay, how we calculate the molar volume? By using this ideal gas formula, V is equal to nRT by P. Understood? By using this formula, we get the molar volume of given gaseous substance. Okay, understood? So what do you mean by molar volume? Volume occupied by the 1 mole of any substance in the gaseous state at a given temperature and pressure is called to molar volume. Okay, here the 3 conditions are given. First condition at 273 Kelvin, that is the 0 degree Celsius. Okay, 273 Kelvin temperature at 1 bar pressure, that is the 0.987 atmospheric pressure. What is the molar volume of gas? 22.71 liter. At a second condition, at 273 Kelvin temperature and 1 atmospheric pressure, we get what is the molar volume of gas? How much volume occupied by the gas? 22.4 liter. Okay, and another one condition at a room temperature, okay, 298 Kelvin temperature at 1 atmospheric pressure. What is the molar volume of gas? How much volume occupied by the 1 mole of gas? 24.47 liter. Understood? These are about the molar volume of gas. We are going to study about gram equivalent concept. Okay, equivalent concept. Before that, it is very essential to know the atomic masses of some important elements. Okay, for our mass calculation and molecular mass calculation, these nearly 25 or 26 elements we are frequently using. Okay, so it is need to study these elements, important elements and their atomic number and atomic mass. You should study this. Okay, so 26 elements I have written. First one, hydrogen. You know, hydrogen atomic number 1, atomic mass 1.008. And then lithium atomic number 3, atomic mass 7. Sodium atomic number 11, atomic mass 23. Okay, after that, potassium atomic number 19, atomic mass 39. Beryllium atomic number 4, atomic mass 9. Magnesium atomic number 12, atomic number 12, atomic mass 24. And calcium atomic number 20, atomic mass 40. Chromium atomic number 24, atomic mass 52. Manganese atomic number 25, atomic mass 55. Iron, Fe, atomic number 26, atomic mass 56. Cobalt atomic number 27, atomic mass 59. Then nickel atomic number 28, atomic mass 59. Copper atomic number 29, atomic mass 63.54. Zinc atomic number 30, atomic mass 35.38. Boron atomic number 5, atomic mass 12. Carbon atomic number 6, atomic mass 12. Nitrogen atomic number 7, atomic mass 14. Oxygen atomic number 8, atomic number 6, atomic mass 16. Aluminium atomic number 13, atomic mass 27. Silicon atomic number 14, atomic mass 28. Phosphorus atomic number 15, atomic mass 30. Sulfur atomic number 16, atomic mass 22. Chlorine atomic number 17, atomic mass 35.45. Okay, so remember these elements, atomic number and atomic mass. If you are studying these elements, atomic number and atomic mass, it is very easy to calculate the molecular mass. And another some calculations, it is very need. Okay, understood? So everyone should write these elements and their atomic number and their atomic mass in your note. Okay, and then we are going to study about gram equivalent concept. Okay, before you are studying the gram equivalent concept, you should study what do you mean by equivalent concept. Okay, so in previous section we had understood that mole concept. So mole concept is based on molecular mass. Okay, mole concept, it is based on molecular mass. because the molar mass defines the mass of the 1 mole of the substance. Okay, so mole concept based on molecular mass. Similarly, the equivalent concept, the gram equivalent concept, it is based on equivalent mass. Okay, gram equivalent concept, it is based on equivalent mass. Okay, so what do you mean by equivalent mass? What do you mean by equivalent mass? Equivalent mass means the combining power of an element or compound or ions. Okay, that is called equivalent mass. So equivalent mass means combining power, combining how much mass substance are combined, or how much mass substance are displaced. That is the equivalent. Okay, how many ions or molecules are displaced, how much mass, that is called the equivalent mass. Understood? So correct definition in your book having the gram equivalent mass definition, it is defined as the mass of an element that combines or displaces. Mass of an element that combines or displaces 1.008 gram hydrogen or 8 gram oxygen or 35.5 gram chlorine. Okay, here what do you mean by gram equivalent mass? It is defined as the mass of an element, weight of an element that combined with any other element or displaces. Okay, displaces. What are the elements? 1.008 gram hydrogen or 8 gram oxygen or 35.5 gram chlorine. These are about the gram equivalent mass. Okay, how much mass is mass of an element that combines or displaces. What are the elements here given as the standard? Hydrogen, oxygen and chlorine. How much weight? 1.008 gram of hydrogen, 8 gram of oxygen and 35.5 gram of chlorine. These three elements, it is taken as the standard. Okay, this much gram of hydrogen, this much gram of oxygen, this much gram of chlorine. Understood? So, for example, okay, consider one of the equation, the zinc, it reacts with sulfuric acid. What is the formula for sulfuric acid? H2SO4. Okay, here the reaction takes place when you are mixing the zinc powder with the sulfuric acid, the zinc, it displaces, when it combines with the sulfuric acid, the zinc displaces the hydrogen from the sulfuric acid and zinc sulfate is formed. Zinc sulfate is formed plus hydrogen gas is evolved. Understood? This is one of the equation. So what is the equivalent mass of this equation? Here, which one is displaced hydrogen? Zinc only displaces the hydrogen. So what do you mean by equivalent mass? Equivalent mass defined as the mass of an element. Mass of an element. This one of the element zinc. So mass of the zinc. How much mass of the zinc it displaces? Okay, here displacement reaction only takes place here. How much grams, how much weight of the zinc it displaces the hydrogen from the sulfuric acid. Okay, this is our question. So in this reaction here, no any one numbers here. So 1 mole we are taking, we consider as this 1 mole of zinc, it reacts with 1 mole of H2SO4 it will form 1 mole of zinc sulfate and 1 mole of water. Okay. Sorry, 1 mole of hydrogen. 1 mole of hydrogen, not water. So here, the 1 mole of zinc, here only 1 mole of zinc, it react with the sulfuric acid. This 1 mole of zinc, so 1 mole means how much grams are having? What is the atomic mass of zinc? Zinc atomic mass what? 65.38. Okay, so 1 mole of zinc, that is 65.38 gram of the zinc. It displays 1 mole of hydrogen. How much moles are having here? 1 mole. 1 moles are of hydrogen. Okay, 1 mole of hydrogen molecule. So 1 mole of zinc displaces 1 mole of hydrogen molecule. So 1 mole hydrogen molecule, this 1 mole hydrogen molecule, what is the weight of this 1 mole of hydrogen molecule? So hydrogen atomic weight 1.008 atomic mass. Okay, but here 1 mole of hydrogen molecule has 2 atoms of hydrogen. So we can multiply the atomic mass of hydrogen with 2. Okay, because 2 hydrogen atom having for the 1 mole of hydrogen molecule. So we get 2.016 gram. Understood? So in this reaction, 1 mole of zinc displaces 1 mole of hydrogen. 1 mole of hydrogen molecule. There is what? How much gram? 2.016 gram hydrogen zinc displaced. Okay, understood? So we need, what is our question? What do you mean by gram equivalent mass? Gram equivalent mass defined as the mass of an element that combines or displaces 1.008 gram of hydrogen or 8 gram of hydrogen or 35.5 gram of chlorine. Here how much gram of hydrogen displaced? 2.016 gram of hydrogen is displaced, but we want how much gram of zinc displace 1.008 gram of hydrogen. Okay, so how we can calculate? So this is the atomic mass of zinc, that is 65.38. This is atomic weight of zinc. So atomic weight of the 65.38 gram of zinc displaces 2.016 gram of hydrogen. But we need, what is the weight of zinc? It displaces 1.008 gram of hydrogen. Okay, so 65.38 divided by 2.016. 2.016 is the weight of the hydrogen molecule, 1 mole of H2 molecule. But we need 1.008 gram of hydrogen. Okay, so 65.38 divided by 2.016 into 1.008. Understood? Now we get the answer. The 1.008 divided by 2.016, we get 2. Understood? So 65.38 divided by 2 is equal to, what is the correct weight? 32.69. 32.69. Understood? This is the equivalent mass of zinc. This is the equivalent mass of zinc. Understood? So the 32.69 gram of zinc. Okay, 32.69 gram equivalent mass of zinc. It displaces the 1.008 gram of hydrogen. Understood? This 32.69 gram per equivalent of zinc displaces 1.008 gram of oxygen. Understood? So this is equivalent mass of zinc, that is 32.69 is the equivalent mass of zinc. But what do you mean by gram equivalent mass? Gram equivalent mass means the equivalent mass, it represents as gram per equivalent. That is called the gram equivalent mass. The equivalent mass can be written as gram per equivalent. That is called the gram equivalent mass. Okay, so here what is the gram equivalent mass of zinc? That is 32.69 gram per equal. Gram per equal. Okay, understood, students? And this equivalent mass has no unit, but the gram equivalent mass has unit, that is gram per equivalent. Understood? So it is not always possible to apply the above mentioned definition, which is based on three references, namely hydrogen, oxygen, and chlorine. Okay, so this gram equivalent mass, this equivalent mass factor, it related to the three elements. Three reference elements. What are three reference elements? 1.008 gram hydrogen, or 8 gram oxygen, or 35.5 gram chlorine. Okay, so but we cannot conceive of reactions involving only with those three reactions. Okay, we cannot conceive of reactions involving only those three reactions. Understood? So therefore a more useful expression used to calculate the gram equivalent mass. Okay, we need the more useful calculation for all the conditions of reactions. Okay, so that is the gram equivalent mass is equal to molar mass. Gram equivalent mass is equal to molar mass. What is the unit? Molar mass means gram per mole. Molar, what do you mean by molar mass? What is the unit of molar mass? Gram per mole. Molar mass by equivalence factor. Equivalence factor. What is the unit of equivalent factor? Equivalent per mole. Equivalent per mole. This is the gram equivalent mass formula. So here molar mass, the mass of the substance is 1 mole of the given substance. Okay, the molar mass means mass of the substance is 1 mole. Okay, so equivalent, what do you mean by equivalent? Equivalent means the number of ions or electrons or elements are displaced. That is called the equivalent factor. How much number of elements or ions are displaced. Okay, that is the equivalent factor. Understood? So using this expression, on the basis of this expression, we can classify the chemical entities, whatever chemicals are involving chemical entities, and how find out the formula for calculating equivalent mass. We should find out the formula for calculating the equivalent mass. Okay, so how the calculating the equivalent mass, tomorrow we will study about that. Okay, so which expression? This is gram equivalent mass is equal to molar mass by equivalent factor. So this expression only, this common expression, this is not basis of the hydrogen, oxygen, and chlorine. Okay, so hydrogen, oxygen, and chlorine, this formula, it is not based on the hydrogen, oxygen, and chlorine. Okay, so gram equivalent mass, it is the common definition. This defined as the mass of an element that combines or displaces 1.008 gram hydrogen, or 8 gram oxygen, or 35.5 gram chlorine. Okay, this is the common definition, but this expression, it is different from this definition. Okay, so commonly if you are simply calculating the gram equivalent mass, it is based on hydrogen and oxygen and chlorine. Now I am giving the three formulas. Okay, it is not in your textbook. It is the common formula. Okay, so this expression we are using, we are going to study tomorrow this expression on the basis of this formula. Okay, but I am giving the three formulas. It is based on the hydrogen, oxygen and chlorine gram equivalent mass. Okay, so the equivalent mass is equal to the first one. Equivalent mass is equal to the mass of the element. Mass of the element means, what do you mean by mass of the element? Suppose this reaction, consider this reaction, zinc plus sulfuric acid gives zinc sulfate plus hydrogen. Okay, so mass of the element means here we are taking zinc. In this reaction we are taking zinc as the mass of the element. Understood? The mass of the element by the mass of the hydrogen. Okay, so because in this reaction we are going to displace the hydrogen from the sulfuric acid. Zinc will displace the hydrogen from the sulfuric acid. Okay, that's why we are using this formula. Which formula? Equivalent mass is equal to the mass of the metal. The zinc is one of the metal. So mass of the metal. What is the mass of the zinc? 65.38. Okay, mass of the element divided by mass of the hydrogen. Okay, because here hydrogen will be displaced. Okay, so mass, how much mole? Total mass of the hydrogen. How much mole is displaced? Okay, that mass into 1.008. Okay, 1.008. It is the common for the definition. Okay, understood? This is for the one formula. Another one formula, suppose if you are displacing the oxygen. Okay, so this reaction, the zinc displaced the hydrogen molecule. Okay, suppose when any another one reaction that bases the another one element, it displays oxygen. Okay, oxygen from any other substance. We are using that formula, the simple formula, that is equivalent mass is equal to the mass of the element divided by mass of the oxygen. Okay, so here zinc displaced the hydrogen. Okay, so and suppose any other element displaces oxygen. We are using which formula? The mass of the element by mass of the oxygen into what is the weight of oxygen given in the definition? 8 gram of oxygen into 8. Understood? And suppose if you are displacing the chlorine, okay, another reaction, if you are displacing the chlorine from their substance, we have to use another one formula. The equivalent mass is equal to the mass of the element by mass of the chlorine. How much chlorine we want to displace? Okay, how much chlorine molecule displaced? That mass. Okay, the such mass. Understood? Into what is the mass of the chlorine given in your definition? 35.5 into 35.5. We get the equivalent mass of the element. Understood? So the equivalent mass defined as the mass of an element that combines or displaces 1.008 gram hydrogen or 8 gram oxygen or 35.5 gram chlorine. This is the equivalent mass. Suppose the equivalent mass, if we are writing the gram, okay, we are giving the unit gram to the equivalent mass of the element. We can say that gram equivalent mass. Understood? Understood? So for this reaction, zinc plus H2SO4 gives zinc SO4, zinc sulfate plus hydrogen. In this reaction, zinc displaces the hydrogen. 1 mole of zinc displaces 1 mole of hydrogen molecule. Okay, understood? So here mass of the zinc we know 65.38 mole. 1 mole of zinc 65.38 gram divided by 1 mole of hydrogen molecule, that is 2.016 into what is the weight of the hydrogen given? 1.008. So we get 32.69 mass of the zinc. The equivalent mass of zinc is 32.69. So here 32.69 gram of the zinc will displace 1.008 gram of hydrogen. Understood? That is the equivalent mass of zinc, 32.69. Okay, if you are writing the equivalent mass in gram, that is called gram equivalent mass. Gram equivalent mass. So gram equivalent mass of zinc is equal to 32.69 gram equivalent. Gram per equivalent. Gram per equivalent. Okay, gram equivalent inverse. Understood? These are about the gram equivalent concept. And tomorrow we will study how we can classify the we can classify the chemicals. Okay, there is acids or basic or oxidizing and reducing agent, and how we can find out the formula to calculate the gram equivalent mass. Tomorrow we will study. Okay, students, take page number 9. Take page number 9. The three definitions today I am going to mark. 3 definitions. First one, what do you molar mass? What do you mean by molar mass? Okay, what is molar mass? The molar mass is defined as the mass of 1 mole of the substance. Mass of 1 mole of the substance. Okay, the molar, this is the definition only. And the molar mass of a compound is equal to the sum of the relative atomic masses of its constituents expressed in gram per mole. The molar mass of a compound is equal to the sum of the relative atomic masses of its constituents expressed in gram per mole. Up to here, I have to mark. Okay, for example, molar mass of glucose is equal to 180 gram per mole. And then second question, what do you mean by molar volume? Molar volume. Okay, the molar volume means the volume occupied by 1 mole of any substance. The volume occupied by 1 mole of any substance in the gaseous state at a given temperature and pressure is called molar volume. Okay, the volume occupied by 1 mole of any substance in the gaseous state at a given temperature and pressure is called molar volume. Okay, if you can study, you should study this. The volume occupied by the 1 mole of gaseous substance, it is the 273 Kelvin, and 1 bar pressure is 22.71 bar. For the 1 more question is important. Okay, and 273 Kelvin and 1 atmospheric pressure, what is the volume occupied by 1 mole of any substance? That is 22.4. Okay, and the temperature different here, 298 Kelvin and 1 atmospheric pressure, that is standard ambient temperature and pressure. Okay, room temperature, there is the 24.47. Okay, volume occupied by 1 mole of any gaseous substance is 24.47. Okay, and then another one definition, what is gram equivalent mass? What is gram equivalent mass? The gram equivalent mass is defined as the mass of an element that combines or displaces 1.008 gram hydrogen or 8 gram oxygen or 35.5 gram chlorine. Up to here I have to mark. Okay, important. These 3 definitions you should study. Understood? Important definitions. And today's assignment, okay, so students, please study daily portion daily. Okay, suppose you don't have the time, if you're not having any time to study, you should read. Okay, once you should watch, after you're watching the YouTube class, you should just you read the concept. Okay, read and understand, then only you can understand anything. Okay, when you are recalling, you can understand. Okay, so and now we are studying, now we are preparing for the midterm examination. For the midterm examination, 3 and 4th, 3rd and 4th unit you have to study. Okay, so this is the revision time, but no time. We have to complete the syllabus. That's why I'm taking the lessons. Okay, so sidewise you have to study the revision also. Okay, page number 123, the 4th lesson we did not complete still now. Page number 123. So up to 33 questions we studied, okay, in last class. So today 34, 35, 36, 37, 38. Okay, 35, 34, 35, 36, 37 and 38. These 5 questions. Explain the exchange reaction of deuterium. How do you convert parahydrogen into orthohydrogen? Mention the uses of deuterium. Explain the preparation of one hydrogen using electrolysis. And one more problem, question is also having. These 5 questions you have to study. Okay, side by side you have to study the book in question also. Okay, thank you students, thank you.